Good morning, students. Uh, I would like to cover, say, during holidays, one more unit, and probably I'll try to send you the lectures online. The first chapter in the third unit we'll be talking about is today rotational motion and kinematics of elastic and inelastic collision. So the first thing which you have already done in your lower classes, kindly try to recollect them, and I'll also cover them in short regarding rotational motion. So the first topic on this is, what do you mean by angular velocity, what is angular acceleration, what is torque, and then what is how the angular momentum is conserved. So these are few topics in the rotational motion, and which I'll try to cover in few minutes. It will be just quick revision for you, and then you can see yourself. The first is, what is angular velocity? So angular velocity, you see, whenever we have a circular motion where the angle changes at every second. Body is revolving in a circle. Say for example, the body is at point P. This is body is at point P, and after a certain period of time, it reaches at point Q. Then let us say that d theta or delta theta is the small angle which this body will cover once it go from point P to Q. And let us say this delta t is the time taken to go from point P to point Q. Then you see the angular velocity is denoted by letter omega, and omega is always equal to d theta over dt, and the units will be radians per second. Or similarly, say for example, what is the exact mathematical form of writing an angular velocity? We write omega is equal to limit delta t approaches to 0, means delta t is very small. For a small interval of time, we are measuring all these things. If limit delta t approaches to 0, this is delta theta by delta t, which is equal to d theta over dt. So this is how we write the angular velocity. Then comes angular acceleration. Then, as you know, what is acceleration? Acceleration is the rate of change of angular velocity. So this is alpha. It is denoted by letter alpha, and alpha is equal to d omega by dt. If it is d omega by dt, substitute the value of omega, d dt of d theta by dt, which is d2 theta by dt square, and the units will be radians per second square. So this is your angular velocity. This is angular acceleration. Once a body is moving, is having a rotational motion. Then comes the angular momentum. Angular momentum, you see, it is denoted by letter capital L. Capital L. And capital L is always equal to I into omega. What is I? I is called moment of inertia. These all things you have done in your +2 classes or +1 classes. So L equal to I omega, where I is moment of inertia. So we differentiate this equation here. We write dl over dt is equal to d dt of I omega. I omega. But as we know that what is the relation between torque and angular momentum? This is dl over dt is always equal to torque. Torque tau. So instead of writing dl over dt, we write here torque tau, and this is equal to d dt of I omega. Now you see, we know that if no external torque is applied, if no external torque is applied, means the value of the torque is equal to 0. So when no external torque is acting on the system, then tau equal to 0, and which implies that d dt of I omega is equal to 0, or d dt of I omega equal to 0. So derivative of a quantity is equal to 0 means the quantity is constant. So I omega is constant and I omega equal to L. So L is constant. So this is called the conservation of angular momentum. So you will try to see all these small articles. What is angular velocity, angular acceleration, then angular momentum, what is torque and torque, etc. And you can also see that L is equal to this also relation. You can see L is given by R cross P, where P is equal to mv. So mvr, L equal to mvr. So these are the small say relations, which are 3-4 topics which are there in their rotational motion. So just try to see, and in brief I have covered all these. So just try to make your notes accordingly for this. Now next comes the main topic of this unit, which is, what do you mean by elastic and inelastic collision? What is elastic and inelastic collision? So before that, first thing we will be writing what is collision. So you see, collision means what? Collision means if you have two bodies, then the interaction of these two bodies, the interaction of the two bodies, where the magnitude and you see the further, you can say the direction of the two bodies, of the two colliding bodies changes. कि ऐसा collision होगा जहां पे दो bodies interact करेंगे और उसके बाद उसका magnitude और direction of the two bodies will definitely change, and that is called a collision. So collision is this. Then comes the types of collisions. We have types of collision. So types of collision, there are two types of collisions. One is called elastic collision and second is called inelastic collision. Now what is the difference between these two? The collision is said to be elastic if both kinetic energy and momentum of the system remains conserved. Say for example, there are two interacting bodies of masses m1 and m2 and they collide. Once they collide, and if we check that what is the kinetic energy and momentum of the system on collision, then if both of these kinetic energy as well as the momentum remains conserved, we say the collision is elastic. So elastic collision में क्या होगा? Elastic collision में आपके पास the kinetic energy and momentum will always be conserved. And here in this case, you see the kinetic energy is not conserved, but the linear momentum or momentum is always conserved. So this is the difference between these two collisions, elastic and inelastic collision. Say for example, elastic collision का example आप देख सकते हो, the collision between atomic and subatomic particles. Subatomic particles, when they collide, then the collision is always considered to be elastic collision. Or say for example the collision between two ivory balls. Ivory balls कौन से हैं? जैसे billiards है, snooker है, उसके दो balls अगर strike करते हैं, then you see again the collision is said to be elastic. So these are the say examples of this. So further, first type is elastic collision. So we'll be talking about elastic collision first. So elastic collision we will be discussing. So for that matter, we will be drawing this diagram. Let us say this is particle M1. We are talking about now elastic collision. And the diagram is M1 is first mass. Let us say it is moving with the velocity U1. And here we have mass M2, which is moving with the velocity U2 in this manner. And let us say that U1 is more than U2, तो ये क्या करेगा? इस ball small से इस mass से collide कर जाएगा. And let us say that after collision, what happens? This mass M1, it goes this way. ये mass M1. M1 moves this way, and let us say its velocity is V1. And similarly, let us say that the mass M2 goes this way. ये M2 mass इधर आ गया. And it moves with the velocity v2 after collision. And let us say this angle which it makes with this horizontal is theta. Sorry, let us say this angle is phi. And let us say that this angle is alpha. This angle is phi and this angle is alpha. This is y-axis, y dash, and this is x. Now in this case, you see, we have drawn this diagram. We have taken two masses, M1 moving with the velocity U1, M2 moving with the velocity U2, and then after collision it goes this way, it goes this way, it makes an angle phi with this horizontal, and alpha is the angle which M2 will make with this horizontal, and their respective velocities is V1 and V2, and these are the respective y-axis. Now in elastic collision, what I said that the kinetic energy and momentum that remains conserved. So in this case, you see, if I write this equation, the law of conservation of energy, now apply to this diagram, we can write half m1 u1 square plus half m2 u2 square is equal to half v1 square plus half m2 v2 square. This is the law of conservation of energy. Then this equation must hold good as far as the elastic collision is concerned. Number one. And number two, conservation of momentum. Conservation of linear momentum क्या कहता है? Conservation of linear momentum. What it states, that is, before collision is m1u1 plus m2u2 is equal to m1v1 plus m2v2. ये तो जर्नल इक्वेशन आ गई यहाँ पे कि this is the law of conservation of momentum. Now we'll be writing this momentum along x-axis and along y-axis. Now you see along x-axis. Along x-axis क्या है? m1u1 plus m2u2 is equal to, now I see ये m1 v1 इधर जा रहा है. What is the component of v1 along this, along x-axis? We are writing momentum along x-axis. तो x वाला लिख देते सामने. The component of v1 along this axis is v1 cos phi. ऊपर को जाएगा v1 sin phi. तो what will be the momentum? Mass into velocity. Velocity का component इधर क्या है? v1 cos phi. ये वाला component. This is v1 cos phi और इसका कंपोनेंट v2 का इधर क्या आएगा? v2 cos alpha. ये देखो x एक्सिस की तरफ, इसका कंपोनेंट इज v1 cos phi, इसका कंपोनेंट इस तरफ v2 cos alpha. So this is v1 और मोमेंटम क्या आएगा? मास इनटू वेलोसिटी. मास कितने? m1 v1 cos of phi plus m2 v2 cos of alpha. This is the component along x-axis. Similarly, along y-axis. Along y-axis. So, is there any motion of these particles m1 and m2? They are moving along x-axis. There is no motion along y-axis. So, what is the momentum before collision along y-axis? Is 0. So, this is 0 plus 0 is equal to, now what is the component of this momentum along this side? This is m1 v1 sin of phi. ऊपर की तरफ m1 v1 sin phi. यहाँ पे मोमेंटम इधर जाएगा m1 v1 sin phi और इसका कंपोनेंट वर्टिकल ये है यहाँ पे. So this will be m2 v2 sin alpha. So we will be writing m1 v1 sin phi और ये इसके ऑपोजिट है तो माइनस m2 v2 sin of alpha. So these are the components and these are the collisions and how the this linear momentum and kinetic energy is conserved and what are the components, how do we write all these components as far as this the elastic collision is concerned. Now we will be talking about inelastic collision. So inelastic collision में क्या होगा? Only the momentum part will be conserved and kinetic energy will not be conserved. So second is your inelastic collision. Inelastic collision. So here you see, here I told you that linear momentum remains conserved but kinetic energy does not remain conserved. यहाँ पे kinetic energy does not remain conserved but linear momentum is conserved. So in this case linear, तो kinetic energy, देखो kinetic energy को क्या होगा? Kinetic energy of the system will decrease. Initial kinetic energy ज़्यादा होगी because once it will strike the ball, the balls को वो transfer करेगी energy, so some of the energy is lost. So here in inelastic collision, you see the kinetic energy before collision. What is that? Before collision, kinetic energy. This is half m1 u1 square, half m2 u2 square, and it is always greater than the final kinetic energy, half m1 plus half m2 v2 square. There is always a difference of energy, and where the energy goes, initial energy is more and final kinetic energy is less. So where the energy goes, it is lost or one form into another form इसमें change हो जाती है. And once you see if the two billiards ball or snooker ball they are striking, तो उसमें क्या आता है? आपको आवाज भी सुनाई देती है. Once the balls collide, you hear some noise and there's a sound energy. तो इनिशियल एनर्जी थी वो फाइनल में क्या होगी, कुछ साउंड एनर्जी में कन्वर्ट होगी और कुछ जाके मोशन में चलेगी, फाइनल काइनेटिक एनर्जी. सो यू सी heat may be okay, sometimes you see these balls collide, then slightly their temperature also changes on collision. So heat energy or sound energy that comes into play, and therefore the final kinetic energy is less than that of the initial kinetic energy. That is why energy does not remain conserved. तो एक तो ये हो गया आपका. एंड सेकेंड उसमें क्या रहेगा, मोमेंटम कंजर्व रहेगा. नाउ यू सी वी हैव टाइप्स ऑफ कोलिजन भी आप कह सकते हैं. तो इलास्टिक एंड इलास्टिक, देन the collision can take place in 1 dimension, in 2 dimension, and in 3 dimension. Once the collision is taking along a single line, line क्या होती है 1 dimension, then we say this is 1 dimensional collision. If the collision is taking place in a plane, then we say this is 2 dimensional. And if the collision is taking place in space where the 3 coordinate axes they are involved, then we say that this is 3D collision. So this is all about this. Now next is, what do you mean by inelastic collision and coefficient of restitution? तो इन इलास्टिक कोलिजन में आपके पास क्या है, हमने ये बता दिया, एक तो एनर्जी इसकी क्या रहेगी, ये चेंज हो जाएगी यहाँ पे. एंड देन इसी में आगे हम ये डिफाइन करेंगे, वी विल डिफाइन दैट व्हाट इज कोएफिशिएंट ऑफ रेस्टिट्यूशन.